Well, OK, so why not use an XML schema or DTD to actually validate the HTML markup? The short of it is that browsers only care about adherence, in theory, to a minimal set of standards. The data hyphen roles are meant to be unique to any old website. You could require that individual websites produce a DTD or schema or RelaxNG schema for their HTML. But I think the world just doesn't care enough to actually do that. I mean, I think that you could. You absolutely could. That would be a much more rigorous design. But I mean, we live in a world where they don't even require us to close some of our tags. And so that's kind of the mindset, I think, in general. Other questions? All right, so better, and if you're making a mobile website, and such as the one I demoed last week, the CS50 Fair mobile website, we did that little trick where we moved the scroll bar up so you didn't actually see the address bar by default. And it's better than having to roll all of those features yourself with CSS and JavaScript. So it's a way of getting started typically quite quickly. So the little tour there of frameworks. All right, so what about tools? So version control. So this is something we kind of sort of use in 50. In higher level classes, hopefully you've made more frequent use of this. And for this class, you will necessarily have to use version control. Specifically for standardization's sake, we'll use Git for the class, which alongside Mercurial and Subversion is kind of on its way out, are really among the top contenders these days. They're pretty much Git. Mercurial, Bazaar is another one. These are known as distributed version control systems, which are a leap beyond things like SVN, CVS, and older ones. Long story short, if you've ever used SVN or similar, these typically rely on a central repository. So you and your partner and your other colleagues all have local copies of some website or some program. And when you want to share that code or save that code for perpetuity to the central server, you quote unquote push it to or commit it to a remote server. The downside here is that as you're making local changes on your own laptop or desktop, if you're using something like SVN, you can push to the remote server, but you can't maintain versions in the same way in your local directory. So thus were born distributed version control systems like Git and Mercurial and others that allow you to not only commit your code, save different versions, differentials, as often as you would like in your own local directory. They also then let you push to a similarly designed central server, but you can also pull directly from your colleagues and such. So particularly in large organizations where it's not just you and a partner, it's you and 10 people, you and 500 people, you can actually share collaboratively and merge other people's code, source code files into your own work, give them your work, and so this is where things are going. So just to paint a picture of this, and we'll spend more time on this in labs, there's a few pieces of jargon that underlie most of these systems. If you think of this as a timeline going from top to bottom, on the right-hand side there we'll call the master branch. The master branch is the product that you care about. And every one of those little blue circles represents an interesting commit where you rolled out some feature and pushed it into the central server. But along the way, you might want to experiment, or different people might want to work on different things. And it's kind of a bad thing if everyone's working on the master branch, because if one person has a bug, commits that bug to that central branch, who does it affect? Absolutely everyone. So the idea of these systems is that you can, quote unquote, branch off of the main branch and have your own little branches depicted here as little yellow dots along this line that let you work on individual features and only merge back from left to right into the master branch when you have rigorously tested your code, it's been reviewed by some number of colleagues, and you're sure that you're not going to break the entire website. So companies like Facebook and others that are actually constantly pushing out changes to the website do engage in processes like this, where you work on your own branch, and you only are allowed to merge it into the master branch once you know it's not going to take down all of Facebook. That's at least the theory of it. But I'm sure all of you have tripped over bugs in Facebook and the like nonetheless. All right. If you really want to wrap your mind around this, gets sophisticated over time. And when there's more than just you and a friend, you can divvy things up, as this tutorial here has. We'll post this link online on the slides. But you can traverse a tree that is your source code repository. So what does this mean in real terms? Well, what it means, when you first sit down to do a project for the class, working with your partner, both of you, or well, at least one of you initially, will create an empty directory, maybe start writing some code, but the moment you're ready to share that code or commit it to some central server, you're going to run a command like git init for initialize this directory. What does that do? It stores an invisible directory called .git in your current directory where a lot of metadata is stored. All of the differentials between files that you've saved. You can then add files to that repository. You can commit, which means save files to that repository. You can push files from your repository to a remote server. Conversely, you can clone the repository. In 50 this past year, some of you might have used the clone command to download lecture examples or pset distribution code. And you can also pull from another friend, which means don't make a copy of it. It means integrate everything into your own code. So for the course, there's a bunch of options out there. We've decided to use Bitbucket because, one, it's free, and two, because they give you unlimited private repositories. So you might, the biggest player out there is GitHub, which charges a fortune to actually have a non-trivial number of private repositories. Private just means only you and people you authorize can access your code. GitHub is meant to be more social, so if you've heard of this company, they're wonderfully popular, especially for open source projects, but by default, all of your code is open, which means when you push to the central server, it means the whole world can then pull or clone it themselves. Not ideal for a class, not ideal when you're collaborating on something of your own design. Bitbucket, though, is similarly free. It's because they want you to buy their non-free products, presumably, but they provide you with unlimited code repositories, so private repositories. So the first project spec will walk you through the process of setting this up, but what this is going to mean is both you and your partner will have one of these repositories. One of you will set up the project initially, and then you'll be able to collaborate with each other by way of committing code to the central server. The staff and in the future classmates can actually see your code and actually browse it on this website as well. They have nice little wiki and bug tracking features of it. So in short, we'll use a real world source code repository so that your experience is as real world as possible. Yeah?
Does that mean we have to use Bitbucket for all collaboration?
For the course, yes. You can use, in theory, other repositories, but it's going to have to eventually get pushed into this, which is fine, because the whole idea behind Git is that you can actually push to multiple repositories if you would like. All right. That was a lot. Let's take a 5-minute break. All right, so we are back. So a word on the first project. We'll touch base on this at the very end of today. The specification will go online tomorrow. And so that we realize folks have enough time to make sure they have a partner and such, we'll actually have the proposal due this Friday instead of this Wednesday. So website and syllabus and online have been updated. The proposals are fairly low-key. For the staff-assigned projects, the proposal will really boil down to reading the spec and thinking about it and having a brief conversation with your partner about who is going to do what. Figuring out, oh, I'll do the JavaScript, I'll do the PHP, or I'll do the database schema, or also just navigating those kinds of issues. For the students' choice projects, the proposal will be more like a traditional proposal where you have to get together, talk, and figure out what it is you are going to do. So this is a typical release cycle. It fluctuates a little bit because of vacations and whatnot during the term. But next week, for the design document and style guide, you'll be expected, using your Bitbucket accounts, to actually put together both a style guide for this first project and a design doc. What does that mean? So a style guide will be akin to what we show in CS50, where you make some decisions, maybe arbitrary decisions, as to what your indentation is going to look like, where you're going to put spaces. All of the things that we put into the style category in CS50, you're going to have to argue about and have some really stupid arguments with your partner as to which is better, 2 spaces or 4 spaces, or tabs, or putting the curly brace on the same line or different line. We don't care what the outcome is, so long as your code ultimately is uniform. And so among the things we'll be looking for is adherence to your own set of standards. So that's always a fun religious conversation to have. The design document is the more intellectually stimulating part of that conversation you'll need to have. And typically this will involve figuring out what are your database tables, if applicable, going to have to be. How you're going to normalize the tables and put IDs in one field, foreign keys in another, and the like. How are you going to go about designing the PHP code and or JavaScript, really fleshing out in detail in advance how you're going to approach the project so that ideally after that Monday you and your partner can go off autonomously, pretty much build some things independently, having made promises to one another as to what you'll build and how you will interface with one another. So we'll talk this today and Monday and beyond on how to sort of formulate those kinds of conversations. And the idea is that hopefully they will get easier and better over time. If come this weekend you sort of are standing at a chalkboard or hanging out with your partner and you're like, where do we even begin? Like, that's the perfect place to begin a design conversation. And I promise you, by Monday, you will have figured it all out. So thereafter, we'll do a beta version of the product by that Friday. Thereafter will be an opportunity for the staff and classmates to review your code and actually comment on it. And then finally, a couple weeks after this whole process, a formal release date where you ship that code. And it will look amazing at that point. All right. So object-oriented programming. This is something that comes up in CS51 and in some other higher level classes. For those who have less experience with this or none whatsoever, realize that for larger software projects, this is pretty integral typically to a design, if only because it allows you to standardize what each of you are working on in such a way that your code bases that you each write separately can talk to one another a little more cleanly than they might using other techniques. That's not the only way to write code, but it is certainly very popular. So you might recall either from this past year, 2010 or 2009 in CS50, we had the CS50 finance assignment whereby we gave you a bit of skeletal code for talking to Yahoo Finance. And if you called that lookup function, that actually took as input, for those unfamiliar, a stock symbol and queried Yahoo via HTTP and then returned to you, the developer, a object, a struct, really, containing a whole bunch of fields. And in 50, we kind of wave our hands at these details and we say class is a struct, don't worry about it. But there are some interesting details that we gloss over. So classes have more meaning than just structs. Whereas a struct in C is just a container for data fields, a class or an object can have what? So methods, or otherwise functions, sort of inside of the object that perform some kind of operations related to that object. So rather than pass pieces of data into functions, like we talked about on Monday with sorting functions and searching functions, you just take the object in question and you call its own sort or search method. So it encapsulates functionality and data a little more cleanly. In CS50, we just say public, 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 public. And this is really not the right way to leverage classes, because in most languages like PHP and Java and others that support the notion of visibility, you can use special keywords like public and private and sometimes protected, which specifies who can actually access these fields. When you say public, you can probably infer that that means anyone can access it. So in PHP, that means you can simply say something like, let's say S for stock, arrow price, and anyone that has included this file in their own PHP code, upon getting back a stock object, call it S, can access price. By contrast, if in 50 we had made all mentions of public there private, you could not have done this. So the lookup function in pset7 could have handed you back this special object, called it S, that's a stock object, but the data is inside of it. But if it has no public data fields and no public methods, you have no means of getting access to that information at all. So typically what you would do when designing something like this, if I do a quick copy paste, open up a text editor here, and let's say paste this in here. So if I were instead to do a global find and replace here, and let me change all mentions of public to private. So this is not a useful object just yet if I can't actually get at the information inside it. So what we'll see in PHP, as in other languages, is that you can actually expose this information via methods. They're often called getters and setters. Some languages take this to an extreme. But you would typically do something like public function, let's call it getPrice. And then down here, we would do something pretty trivial potentially. Let me scroll up a bit more. We could do something super simple like return this arrow price. So as you might have guessed, this is self-referential. When you're writing code inside of a class, this refers to the object currently in question, so the $S variable. So arrow means dereference it and give me the price field. So the getPrice method here, can access the price field because even though it's private, because the code in question is inside of the class. So by contrast, in CS50 pset7, you, the person using the lookup function that we wrote for you, could not use syntax like this. But you could, if we rewrote the class, do something like this. S $arrow get price. And then you could store that value in, say, a variable called price. So this is a simple example, and it's actually not compelling, because what is the value of this? Right? I've really just made more work for myself, it seems. Yeah?
Why can't you just do return price?
Return price. So if you did return price in, so this is not like Java. In the context of PHP, this would assume it's a local variable called price. Good question. So this is not all that compelling, admittedly. So why even bother?
This way you can change the price from outside of the class.
Yeah, so that's actually pretty compelling, right? Especially in a large system where you might be passing variables around a lot, and you're not immune to writing buggy software. You don't want to accidentally put something like $S arrow price, and then just by accident or copy paste fail, you do something like this somewhere in your code where the assignment's actually on the other side. What you've just